Hello, am I audible?
Yes, sir.
Okay. So in this class, we are going to learn the last one, write once based protocols, which is going to end all the Snoopy based protocols. In the last class, we have learned about what is Snoopy and how to implement Snoopy based bus protocols. And we have come across two different kinds of protocols. One is write through, another one is write back. Yes. So in this
मैं पढ़ेंगे
class,
कहाँ से करके
we are going to just go through the
इन तो
next
सिर्फ
one,
लिखा है क्या
write once protocol. Since we have come across what is meant by write invalidate bus snooping protocol, it is going to have two states, that is valid state and invalid state, and this is how it works. Whereas the problem with write through protocol is high bandwidth requirement, whereas write back caches absorb most writes as cache hits. That's why we go through write back caches for write invalidate bus snooping protocols. Here what will happen is, instead of two there will be three states, and this is advantages over the write through protocol. In this class, we will look about write once protocol. Before that, let us discuss what is invalidate versus update protocol, because write once is an update protocol. What is the difference and how we are going to check? The first and foremost basic question of program behavior, whether is a block written by one processor read by others before it is rewritten. That is write back. What does that means? If there are more than one processor, if there is one block which has been written, while it is writing the block, is it possible for another processor to read it? That is the basic question of the program behavior and where inconsistency occurs. Whereas in case of invalidation, what will happen is readers will take a miss. Yes, it is possible in case of write invalidate protocols, but what will happen is it is going to invalidate, that is the cache is either making it as a dirty or invalid. Then they are going to flush their caches or replace their box either by reading into the main memory or writing into the main memory. In both the conditions, they are going to become into valid state. Whereas write update protocols, the answer is no, because multiple writes without additional traffic, and hence it is not going to have it is not possible to read by others, clears out copies that won't be used again. That is the invalidation protocol. Then in write update, what will happen is readers will not miss if they had a copy previously. Single bus transaction to update all the copies, whereas multiple useless updates even to dead copies will occur in update protocol, because that is stored over there. Need to look at program behavior and hardware complexity. In general, invalidation protocol are much more popular. Some systems provide both or sometimes even called as hybrid protocols. Then update based bus snooping protocols, write operation updates values in other caches, new update bus transaction. The advantages are other processor don't miss on next access. So, and hence it is going to have a reduced latency. In invalidation protocols, they would miss and cause more number of transactions. We have seen how invalidation protocols are going to miss it and hence increase in traffic. Whereas in our write update bus snooping protocol, a single bus transaction to update several caches can save the bandwidth. Also, only the word written is transferred, not the entire block. Whereas in invalidation protocols, what will happen is we are going to tag the block as a 3-state or 2-state, valid or invalid, read write, read only, or invalid. In both the cases, if something happens, we need to replace the entire block, not the single word. Whereas in case of update bus protocols, if any word is updated, only that word is transmitted, and hence it can save a lot of bandwidth compared to the write invalidate protocols. The disadvantages are multiple hello, hello.
Yes, sir.
Sorry, there was a problem on my side, I think. Now, is it hello? Is it visible?
Yes, sir.
Yes, sir.
So ಎಲ್ಲಿ ತನ ಬಂದಿದ್ದೆ ಹೇಳ್ರಿ because there was a connection failure. Further, I have completed the advantages of update based bus snooping protocols. Or shall I need to repeat? Hello? ಕೇಳಾಕತ್ತದ?
Yes, sir.
Shall I need to repeat or I will repeat. The advantages are other processor don't miss on next access, which is reduced latency, whereas in invalidation, they would miss and cause more transaction. One more best advantages is in single bus transaction, it updates several caches and saves bandwidth. How it does is, it will update only the required word, not the entire cache block, which is not present in case of the invalidate protocol. Disadvantages are multiple writes by same processor cause multiple update transaction. In invalidation, first write gets exclusive ownership and others are local. So detailed trade-offs are more complex. We'll come across write once protocol. James Goodman proposed a cache coherence protocol for bus-based multiprocessors. This scheme combines the advantages of both write-through and write-back invalidations. In order to reduce bus traffic, the very first write of a cache block uses a write-through policy. This will result in a consistent memory copy while all other cache copies are invalidated. After the first write, shared memory is updated using a write back policy. This scheme can be described by the four-state transition graph. The cache block which is consistent with the memory copy has been read, shared memory and has not been modified. So when it is in valid state, that is the cache block is consistent with the memory copy, it has been read through shared memory and has not been modified. Whereas in invalid, when the block is not found in the cache or is inconsistent with the memory copy, then it is said to be invalid. When it is reserved, data has been written exactly once since being read from shared memory. The cache copy is consistent with the memory copy, which is the only other copy. The cache block has been modified more than once and the cache copy is the only one in the system, then it is called as dirty. So this is how it is. It is going to have four states. So let us start with the dirty. If somebody writes it, it is going to be command issued by the local processor. Solid lines means, whereas dashed lines are commands issued by remote processors. But when a processor read invalid by other processor, it will move to invalid state. When it is in invalid state, if the processor reads, sorry, this should be valid. There is a small this one in the book, please remember, because I have taken it from the Kai Hong book only, textbook only. There also there is a mistake. Please make it as invalid, sorry, valid. Please save this. So when it is in dirty, read entire, when entire block is read, it will move from dirty to valid state. But if it is, there is an operation called as read invalid by other processor, it will move from dirty to invalid. And when it is in invalid state, if it is going to read the copy, then from invalid, it will move to valid state. If when it is in valid state, when it is going to read it, it is again going to be in read state only. When it is going to have executed read invalidated or write invalidated protocol, it moves from valid to invalid. When it is going to write it, then it is going to be in the valid state only. Then when read operation happens, it will be again comes to valid. But when it is in reserved state without reading the block, if it goes to again writing, it moves from reserved into dirty state. As we have said here, the cache block has been modified more than once and the cache copy is the only one in the system, then it moves from reserved to dirty. When the block is read invalidated, it will move from reserved to invalidate state. Understood? Then the cache events and actions. What will happen to the cache and what are the events and actions? So remember, this is the combination of write through and write back invalidation algorithms. In cache events, the memory access and invalidation commands triggers the following events and actions. Read miss. When a processor wants to read a block that is not in the cache, then a read miss occurs. So normally what will happen is when the processor starts in the beginning, so it doesn't have anything in its main memory, then it is going to definitely read miss occurs. We have called that as compulsory read misses. And when reading a new data, then also a read miss occurs. Then the second one is a bus read operation will be initiated if no dirty copy exists. Then the main memory has a consistent copy and supplies a copy to the requesting cache. So you don't have the data, then what you are going to do is you will request for the bus read operation for that particular variable. Then what memory will check is there any dirty copy exists? That is, if it is accessed by any other processor and if they are written more than once, then it will check. If it is not the case, then the memory has a consistent copy, that is all are in valid state, then it supplies a copy to the requesting cache. So what will happen if the dirty copy does exist in the remote cache? Then that cache will inhibit the main memory and send a copy to the requesting cache. So in case of that, what will happen is the cache which has in dirty, that is which is written more than once, is going to send the copy on behalf of main memory to the requesting cache. In all the cases, whether it is the dirty copy exists or not, in all the cases, the cache copy will enter the valid state after a read miss. Please remember, whenever a see, even if it is in dirty state, then also it will move to a valid state. If it is in reserved state, then also it will move to valid state. If it is in invalid state, then also it will move to valid state. So what will happen is, in all the cases, whether the dirty copy exists or no, or any other scenario, the cache copy will enter the valid state after a read miss. Then write hit. If the copy is in the dirty state or reserved state, the write can be carried out locally. New state is dirty. So, and the copy is in the dirty or reserved state. In case of both, if a write operation has been carried out, then it will be carried out locally. Then it will be in the dirty state only. If the copy is in either dirty or reserved state and then it performs a write operation, then that operation is definitely can perform, but it is locally and the new state is called as dirty state. We know what is meant by dirty state is if the write operation is performed more than once, then we call it as a dirty state. Whereas if the new state is valid, a write invalidate command is broadcast to all caches, invalidating their copies. So let us check. So this is when it is invalid. If it is going to be write invalidate is command is sent to all the processors. So whenever a write invalidate command is sent, all caches are going to invalidate their copies. The shared memory is written through, and the resulting state is reserved after this first write. So, if it is invalid, then it is going to be written through the return to the shared memory also, and the new state is going to be reserved after this first write. So, what will happen if a write miss occurs? When a processor fails to write in a local cache, the copy must either come from the main memory or from a remote cache with a dirty block. So what will happen? Suppose think of an example, if I want to write something, but some processor is already in dirty state. When a processor is in dirty state, it is not going to allow any other processors to write something to the cache. Then it needs to take that from the either from the main memory or from the remote cache with the dirty block. This is accomplished by sending a read invalidate command, which will invalidate all the cache copies. The local copy is thus updated and ends up in a dirty state. Then comes read hit. So when a read hit occurs, read hits can always be performed in a local cache without causing a state transition or using the Snoopy bus for invalidation. So it is just a read, and hence there is no such this one restriction. So it will not change the state. Then finally block replacement. If a copy is dirty, it has to be written back to main memory by block replacement. Since it has written more than once, it needs to be written back to the main memory. If the copy is clean, no replacement will take place. And hence, Godman's write once protocol demands special bus lines to inhibit the main memory when the memory copy is itself invalid and a bus read operation is needed after a read miss. But the problem here is most of the standard buses cannot support this inhibition operation, and hence even though the Godman four-state protocol, write once protocol is best, since most of the standard buses are doesn't support inhibition operation, it is difficult to bring into implementation. This is a write once invalidate protocol. So in this lesson, we learned about write once protocol. Since we have understood by making sense out of the interpretation and summarization about the topics and by knowing the other two protocols. So the important questions on this are explained write once protocol. It has taken by Tai Hong and Naresh Jodhwani book, chapter number 7, pages from 322 to 326. Is there any doubts? Any doubts? So if there are no doubts, we'll stop this, and from tomorrow next week onwards we will have directory based protocols. Okay. Thank you all.